Welcome back, multisensory explorers and AI enthusiasts. Today, we're embarking on a journey into one of the most exciting frontiers of artificial intelligence, multimodal AI. If you've ever been amazed by AI that can understand both images and text, or generate content across different formats, you're about to discover the magic behind these capabilities. Multimodal AI is revolutionizing how machines interact with the world, aiming to see, hear, and understand just like humans do. Let's dive in and explore how AI is learning to process our multisensory world, making technology more intuitive and powerful than ever before. Humans naturally experience the world through multiple senses at once. We see, hear, touch, and understand context simultaneously. Traditional AI, however, has been like having separate specialists, one for images, one for text, and another for audio. Multimodal AI changes this by bringing all these senses together, creating a unified understanding much like our own brains do. Imagine describing a painting with words versus experiencing it with all your senses. Multimodal AI strives for that richer, more comprehensive experience, making technology more human-like and immersive. Let's start with the basics. Multimodal AI refers to artificial intelligence systems that can process and understand multiple types of data inputs at the same time: think, text, images, audio, and even video. The core idea is to combine information from different modalities, creating a richer and more comprehensive understanding of the world. This enables cross-modal reasoning and generation, mimicking how humans perceive their environment. Multimodal AI understands relationships between different data types, translates information across modalities, and generates coherent outputs, making it a powerful tool for complex, multisensory scenarios. To better understand multimodal AI, think of it like a film director. A director doesn't just focus on the script, they also consider cinematography, sound design, and editing all at once to create a cohesive movie. Similarly, multimodal AI brings together text, visuals, audio, and even timing to form a unified understanding. This analogy helps us appreciate how multimodal AI can create outputs that are not only accurate but also contextually rich and engaging, much like a well-crafted film. So, how does multimodal AI actually work? At its core, it uses modality encoders to convert different data types like text, images, or audio into unified representations. Cross-modal attention mechanisms allow these modalities to influence each other, while fusion mechanisms combine information from multiple sources. All of this happens in a shared representation space where different modalities can be compared and related. This technical foundation enables AI to process and understand complex, multisensory information just like we do. There are several key approaches to combining modalities in multimodal AI. Early fusion involves merging raw data before any processing, while late fusion processes each modality separately and then combines the results. Intermediate fusion integrates information at multiple stages of processing. Cross-modal learning allows one modality to help understand another, enhancing the AI's overall comprehension. These approaches give multimodal AI the flexibility to handle a wide range of tasks and data types. One of the most powerful techniques in multimodal AI is contrastive learning. This method teaches the model that certain pieces of information from different modalities, like an image and its caption, belong together, while others do not. For example, the clip model learns to connect images with their textual descriptions in a shared space, enabling it to understand and generate content across formats. Contrastive learning is the secret sauce that makes cross-modal understanding possible. CLIP, or Contrastive Language Image Pre-training, is a groundbreaking model in the multimodal AI space. It learns visual concepts from natural language supervision, connecting images and text in a shared representation space. This enables zero-shot image classification and forms the foundation for many multimodal applications. CLIP's ability to understand both language and visuals makes it a versatile tool for tasks that require cross-modal reasoning. DALL-E and Stable Diffusion are text-to-image generation models that have revolutionized digital art and design. These models understand textual descriptions and create corresponding images, combining language understanding with visual creativity. By bridging the gap between text and visuals, They enable artists, designers, and everyday users to generate stunning images from simple prompts, opening up new possibilities for creative expression. Visual question answering, VQA. Models are another exciting development in multimodal AI. These models can answer questions about images by combining computer vision and natural language processing. For example, given a photo and a question like, "What color is the car?" the model can analyze the image and provide an accurate answer. VQA requires a deep understanding of both visual content and language, making it a true test of multimodal intelligence. Audio-visual models take multimodal AI a step further by integrating sound and visuals. These models can perform tasks like lip reading, speech recognition from video, and sound source localization. They can even generate audio from visual inputs, making them invaluable for applications in accessibility, entertainment, and surveillance. By combining audio and visual data, these models achieve a more holistic understanding of their environment. Multimodal large language models, like GPT-4 Volts and LLAV, represent the next generation of conversational AI. These models can understand and discuss images, documents, and text, enabling true conversations about visual content. Whether it's analyzing a chart, describing a photo, or answering questions about a document, multimodal LLMs bring us closer to natural, human-like interactions with AI. One of the most revolutionary aspects of multimodal AI is its ability to process information the way humans do. By understanding context from multiple sources, it handles real-world complexity with greater ease. This leads to more natural and intuitive interactions, as the AI can draw on a variety of inputs to make decisions and respond appropriately. The result is technology that feels more like a helpful partner than a simple tool. Multimodal AI systems are more robust because they draw on multiple data sources. This redundancy allows for cross-validation across modalities, helping the AI handle ambiguous situations and making it more reliable in real-world conditions. By leveraging information from different types of data, multimodal AI can maintain performance even when one source is noisy or incomplete, ensuring consistent and trustworthy results. By combining the strengths of different data types, multimodal AI can solve problems that single-modal AI simply can't. This enables new types of applications, better generalization across tasks, and more creative, flexible outputs. Whether it's generating art, answering complex questions, or assisting in medical diagnosis, multimodal AI opens up possibilities that were previously out of reach. Multimodal AI offers practical benefits for developers and users alike. With a single model capable of handling multiple tasks, development becomes simpler and more efficient. Users enjoy better experiences, as the AI can provide more comprehensive solutions tailored to their needs. This versatility makes multimodal AI a valuable asset across industries, from healthcare to entertainment. In content creation and marketing, multimodal AI is a game changer. It can generate marketing materials from text descriptions, create social media content across formats, and even automate video production with AI voiceovers. Personalized content at scale becomes possible, allowing brands to engage audiences in new and innovative ways. The creative possibilities are virtually endless. Healthcare is another field where multimodal AI is making a significant impact. These systems can analyze medical images alongside clinical notes, monitor patients by combining visual and sensor data, and assist in surgeries. They also play a role in medical training and simulation, helping professionals learn and practice in realistic, multisensory environments. The result is better patient care and more efficient healthcare delivery. In education, multimodal AI enables interactive learning experiences that combine text, images, and audio. Automated grading of complex assignments becomes possible, and educational content can be personalized to each student's needs. Language learning is enhanced with visual context, making lessons more engaging and effective. Multimodal AI is transforming classrooms and online learning platforms worldwide. Autonomous systems like self-driving cars and robots rely heavily on multimodal AI. These systems process data from cameras, LiDAR, maps, and even voice commands to navigate and interact with their environment. Drones equipped with multimodal AI gain comprehensive awareness, making them safer and more effective in tasks ranging from delivery to search and rescue. Multimodal AI is also driving accessibility innovations. Real-time captioning for videos, image descriptions for the visually impaired, and sign language recognition are just a few examples. These technologies make digital content more inclusive, ensuring that everyone can participate and benefit from the digital world. Despite its promise, multimodal AI faces significant technical challenges. One major issue is the alignment problem, ensuring that different modalities represent the same concepts. Conflicting information between modalities can lead to inconsistencies, and balancing their contributions is a delicate task. Maintaining consistency across outputs is crucial for reliable performance. Curating large-scale multimodal datasets is no small feat. Handling missing or noisy modalities, ensuring temporal alignment for video and audio, and scaling to more modality types all add layers of complexity. These challenges require innovative solutions to ensure that multimodal AI systems are both accurate and scalable. Processing multiple data streams simultaneously demands significant computational resources. Large multimodal models require substantial memory, long training times, and powerful hardware. Achieving real-time performance for applications like autonomous vehicles or live translation is an ongoing challenge that researchers are actively working to overcome. Evaluating multimodal AI is complex. Measuring cross-modal understanding, assessing output quality across different modalities, and benchmarking comprehensive capabilities all present unique challenges. Human evaluation is often necessary, but scaling this process is difficult. Developing standardized benchmarks and metrics is a key area of ongoing research. The future of multimodal AI includes integrating even more senses, such as touch, smell, and biological signals. By incorporating environmental and spatial data, as well as emotional and physiological signals, AI systems will gain an even deeper understanding of the world. This expansion opens up new possibilities for applications in healthcare, robotics, and beyond. Future multimodal AI will feature deeper cross-modal understanding, improved fusion techniques, and more efficient architectures. Real-time multimodal processing will become standard, enabling seamless interactions and faster responses. These advancements will make AI systems even more capable and user-friendly. As multimodal AI evolves, new applications will emerge. Advanced human-AI collaboration, creative partnership tools, scientific discovery assistance, and enhanced virtual and augmented reality are just a few examples. These innovations will transform industries and redefine how we interact with technology. Multimodal AI is paving the way toward artificial general intelligence by achieving comprehensive world understanding, human-like reasoning across senses, and contextual awareness. These systems are moving closer to true AGI. The integration of common sense and the ability to process diverse inputs are key milestones on this journey. In the near future, multimodal AI will be built into everyday applications, providing seamless cross-device experiences and natural human-AI interaction. Ambient intelligent environments will become the norm, making technology an invisible yet powerful part of our daily lives. This integration will redefine convenience and connectivity. Democratization is a key goal for the future of multimodal AI. Accessible tools for creators, open-source models, and educational resources will ensure broad adoption across industries. This will empower more people to innovate and benefit from the power of AI, driving progress and creativity worldwide. As multimodal AI becomes more pervasive, ethical considerations are paramount. Issues like privacy across multiple data types, bias and fairness in multimodal systems, and transparency in cross-modal decisions must be addressed. Responsible deployment guidelines will ensure that these powerful technologies are used for the benefit of all. In conclusion, multimodal AI represents a fundamental leap toward creating artificial intelligence that truly understands our rich, multisensory world. By combining the strengths of different data types, we're building systems that are more capable, robust, and human-like in their understanding. As this technology evolves, It promises to transform how we interact with machines and how AI integrates into our daily lives.